Hi, today we will be talking about humidification, including its application and importance in chemical engineering. This is our team. We have Afif, me, Pinchen, Chunzi, and Shafika. We will be discussing introduction, fundamental concepts, daily life application, and also industrial application of humidification. Humidification is a critical process in various industries, particularly in chemical engineering, where the control of moisture levels is vital for optimal performance and efficiency. Humidification involves the transfer of material between a pure liquid phase, which is water, and a fixed gas, which is air, that is nearly insoluble in the liquid. Basically, it is the addition of water vapor into air. The operation system for humidification is air-water. Humidification occurs when water absorbs energy, evaporates into water vapor, and mixes with air. The energy that the water absorbs is called latent heat. So, there are two ways for humidification to occur. In both methods, energy is added to the water to create water vapor. Firstly, the water is heated. When the heat energy is added to the water is transformed to its gaseous state, which is steam, which mixes into the air. Secondly, the water is evaporated. The fine water droplets absorb heat from the air as they evaporate. The humidification process is quite significant for multiple commercial usages. Firstly, in the manufacturing processes, maintaining the right humidity level can help optimize processes and produce quality products. For example, in the textile industry, humidity helps fabric maintain their elasticity and reduce the risk of tearing. While in gas drying process, humidification is used to remove moisture from wet solids and gases. For example, wet chlorine must be dehumidified before it can be handled in steel equipment to prevent corrosion. Next, in evaporative cooling process, water spray humidification can be used in applications that require evaporative cooling. As the air loses heat to vaporize the water particles, the temperature of the atmosphere drops slightly. While in desalination, it is the technique that uses a heat source to evaporate saline water from a fluid such as air or water. In addition to its industrial application, humidification also matters in everyday life. Humidifiers are widely used in homes and offices, contributing to comfort, health, and well-being. Maintaining appropriate indoor humidity levels can help alleviate respiratory issues, preserve room furniture, and improve overall air quality.
Humidification plays an important role in understanding and controlling moisture levels in various systems. It begins with understanding three key concepts, which is relative humidity, dew point, and psychrometric chart. Let's go with first RH. Represent how much water vapor is in the air as compared to what it can hold in a specific temperature. For example, at 50% RH, the air is halfway to being fully saturated with moisture. So this concept is critical for designing processes like cooling tower and drying chamber. Next, the dew point is the temperature at which air becomes fully saturated and the water begins to condense. In chemical engineering, controlling the dew point is essential to prevent equipment damage and ensure product quality. Controlling the below 50, the air feels super dry, your skin can feel rough, and it is a good time to grab some moisturizer. 50 to 60, this is the sweet spot where the air feels just right, not too dry and not too humid. Life's good and you're comfortable. 61 to 65, things are starting to get sticky. Your sweat doesn't evaporate so fast, so you might sweat. 66 until 70, it's getting uncomfortable. You're sweating in places you don't even know you could sweat, and the air feels heavy around you. 71 to 75, now it's like walking through a cloud. You're drenched in sweat, and the air is so humid it's hard to feel refreshed. Moving to Antarctic might sound tempting. 66 and above, it is absolutely unbearable. The air is so full with moisture and it feels like you're swimming. Your body struggles to cool itself and it's just miserable. The purpose for this psychrometric chart is to graphically represent the physical properties of moist air. Dry bulb temperature, DBT, is air temperature measured by a thermometer. Wet bulb temperature (WBT) is temperature with evaporating cooling effect. Humidity ratio is mass of water vapor per unit mass of dry air. For example, this psychrometric chart is used to design and analyze HVAC systems or industrial humidification setups. Finally, humidification is essential in separation processes, such as absorbing water vapor into liquids or removing moisture during drying process. Each operation relies on precise control of humidity for optimum performance and energy efficiency.
Moving on to the next slide, I'll be talking on the daily life applications of humidifications. While humidifications might sound like something primarily used in industrial settings, it plays a significant role in our everyday life, ensuring comfort, supporting health, and even aiding in agriculture. So, let's start with the basics. Humidification is the process of adding moisture to the air. This is particularly important indoors, where air can often become too dry due to heating or air conditioning. By maintaining optimal humidity, typically between 40 and 60%, we create an environment that is not only more comfortable but also healthier. Dry air can cause various problems, from skin irritation to respiratory discomfort. It can even increase the spread of viruses. That's why humidification is such an essential part of our daily living space. Now, let's look at some specific applications of humidification in daily life. First, in our home and offices, devices like humidifiers and air conditioning systems help maintain air moisture. These are particularly useful in air-conditioned space, where the air can become excessively dry. Proper humidity reduces issues like dry skin, sore throats, and nasal discomfort, improving overall well-being. It also protects wooden furniture and instruments, which can crack or warp in dry air. Next, humidification plays a crucial role in agriculture. In greenhouses, it helps maintain the optimal conditions for plant growth by balancing temperature and moisture levels. This leads to healthier plants and better yields. Additionally, for store crops, humidification prevents produce from drying out, preserving freshness and quality for a longer time. This is vital in reducing food waste. Both in good condition, humidification is a process that supports our daily life in many unseen ways.
So, let's move on to the industrial application of humidification. It might sound simple, but humidification plays a vital role in ensuring the quality, efficiency, and safety across the various sectors, including the textile industry, pharmaceutical industry, and food and beverage production. So now, let's dive into how and why it's so important. Let's start with the textile industry. Have you ever wondered why fibers sometimes break during the production, or why static electricity disrupts weaving processes? The answer lies in improper humidity levels. In textile factory, controlling humidity is critical. Proper moisture level prevents fibers from breaking, ensuring smoother production. Moreover, humidifier reduce the static electricity, which can disrupt spinning and weaving operation. For instance, in cotton spinning factory, maintaining 60 to 70% relative humidity ensure yarns are strong. This not only reduce waste, but also improve the product quality, saving the time and also now. Let's move on to the pharmaceutical industry. Humidification ensures the stability and safety of medicine throughout the production and storage. Without proper humidity, tablets can crack or stick together. Take tablet coating process for example. Maintaining 40 to 60% relative humidity ensure a uniform coating without defects, meeting regulatory standards, and protecting patient safety. Next, we have the food and beverage industry. Humidification is crucial here to preserve freshness and maintaining the quality. For example, bakery rely on humidification to reduce proofing to ensure perfect fermentation. In cheese aging rooms, maintaining 85 to 90% humidity is essential for proper ripening without cracking or drying the outer layer. Proper humidity doesn't just extend shelf life, but it also ensures food taste and looks its best for the So, why is humidification so important across this industry? Let's break it down. First, it ensures consistent product quality by preventing defects, whether it's brittle fiber, unstable medicine, or dehydrated food. Second, it improves operational efficiency. Machine runs smoother and waste is minimized. Third, it ensures compliance and safety, particularly in industry with strict regulatory standards like pharmaceutical and food production. To summarize, humidification protects materials, enhances processes, and supports sustainability.